before?
Yeah.
Mr. Luchek even told some crazy story about SOHCAHTOA. I don't know what it is. I think it changes every year. One year, though, in Precalculus, I can't remember how many years ago it was. And who was it? Someone thought it was true and, like, didn't realize till class, like, in class. She was like, that's not a true story. No, it's not. Okay. Yeah, if you didn't have Mr. Luchek, you are. He tells some story about Princess is it a princess? Yeah, whatever. Okay. I'll ask him about it later. So I knew SOHCAHTOA when I was in school. So is sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, here's what you need to understand. This is all in reference to an angle, so it depends on what angle I'm telling you. For instance, if the angle is down here in the corner, the hypotenuse is always opposite the 90-degree angle. But if the angle is here, where my pen is, that's the opposite piece, and this is the adjacent piece. But what if I moved the angle up here? Then the bottom is the opposite. Okay, so this is why we say opposite the angle, because it depends on what angle I'm referring to. Okay, so sine is the side opposite over hypotenuse, cosine is side adjacent over hypotenuse, tangent is opposite over adjacent. And we memorized. Okay. And what we ended up doing is that if you would type the tangent or the sine of an angle in your calculator, it will calculate it for you. Okay, like if you would say sine of 42 degrees, you're going to get a measure. And we'll start talking about tomorrow how this is where it matters what mode you're in, okay, if you're in radian or degree. And then it allowed us to find missing pieces of triangle. Actually, when I was in school, we didn't have the sine key on our calculator. We actually had, gosh, if I have an old book, I'll show you. We had tables. So, like, you would type in the sine of 42, for instance, and what does it say? If you're in degree mode, I put my calculator in. If you're in degree mode, sine of 42 is 0.669. So what I had to do is, in the back of our book, they had the sine of 40, the sine of 41, the sine of 42, and they had a table, and listed in the table would be 0.669, so I had to go to the back of the table and find the sine of 42 instead of using the calculator. But it was like ages and ages ago. All right, so there are 3 more trig functions, so there's 6 total, and they are reciprocals. The reciprocal of the sine is the cosecant, and so one way you can think of it, a reciprocal, is 1 over, or you can think of flipping the fraction, right? So the cosecant of theta would be, if it's the reciprocal of the sine, what do you think its ratio would be in the triangle? The hypotenuse over the side opposite. Okay? And then that's for cosecant. I'm not going to be able to squeeze this in. So the secant's the reciprocal of the cosine, but as far as the sides of the triangle go, it would be the hypotenuse over the side adjacent. And the cotangent is 1 over the tangent, but as far as sides go, it is side adjacent over side opposite. Okay. And so on today's notes, we're really not going to use our calculators at all. We're going to just use those ratios and the sides of a triangle. So once we find our first 3 really we just reverse them, or not reverse them, we flip the fraction to find the other three. So let's say I gave you, here's theta, the adjacent piece is 21, and the hypotenuse is 29, and I asked you to find all 6 trig functions. Well, what am I missing? But I'm not going to even use my calculator, so I'm not going to figure out what theta is. But I do need opposite, adjacent, and hypotenuse, and I'm missing that, right? What have we learned in the past about the 3 sides of a right triangle? Pythagorean theorem. All right, so let's find this missing piece. 21 squared plus this piece squared equals 29 squared, agreed? So if I wanted to find this, I'll call it x. Okay, 21 squared plus x squared equals 29 squared. So x squared is going to be 29 squared minus 21 squared, and then I'm going to take the square root. However, let's see what we get when we do that, if it's exact or not. Oh, yay, that's so nice when it happens like that. So x is 20. So today, if it's not exact, let's say you got the square root of 15, leave it as the square root of 15, okay? Don't try to type it in your calculator. So this is 20. All right, so the sine of theta is opposite over hypotenuse. So what's opposite? 20 over 29. Cannot reduce it. All right. The cosine of theta is adjacent over hypotenuse, so 21 over 29. And the tangent of theta is opposite over adjacent, 20 over 29. Okay, so now let's do the reciprocal. This is hard for people to remember, and I just remember that it's not what you think it is. Some people think that it's sine and it goes to secant, and because then cosecant is a c, so they think, oh, c goes with cosine. It doesn't. The reciprocal of sine is cosecant. Okay, so if I wanted to find the cosecant of theta, I'm going to take the reciprocal, 29 over 20. The secant of theta is going to be 29 over 21, and at least cotangent sounds like tangent, right? That one's like you think it is. So 21 over 20. Okay, and if we could reduce them, we would reduce them. If there was a radical in there, you're just going to leave it with the radical. Don't divide them or anything. Just leave them as fractions and reduce the fractions if possible, but if not, we're just thinking of them as ratios. Okay, so sometimes I might, this is a similar question, but I give it to you in this way. I'm telling you the tangent of theta is 5 over 12, and I want you to find the remaining trig function. So I'm going to draw a triangle here. Okay, and this is theta. Okay, if I told you tangent, I'm telling you, now they might not exactly be 5 and 12, but when I reduce the fractions, I get 5 over 12, and that's really all I need, because tangent is the opposite over adjacent. So what I'm going to do is I'm going to make the opposite piece 5 and the adjacent piece 12. Okay, doesn't that make that statement true then? Okay. So then let's do the same thing. We're going to do Pythagorean theorem. 12 squared plus 5 squared equals x squared. What do we get? This one's exact too. 13. All right, you guys do it. Would you find, we already did tangent. Would you do sine, cosine, cosecant, secant, and cotangent a second time? Okay, are we good with that?